this is lecture video 48, and in this lecture we will cover this type of integrals where we have products of any powers of tangent x and secant x. Okay, let's start by considering very simple cases of this form, like we know how to integrate secant square x because this secant square x is the derivative of the tangent x, integral of it is tangent x. We also know how to integrate secant x times tangent x as it is the derivative of secant x function. Okay, and we also know how to integrate just secant x, for example. We covered this famous rule like ln secant x plus tangent x, right? And do we know how to integrate tangent x? Yes, you can do it quickly by writing it in the form of sine x over cosine x, and then if you call this part as u, this part will be minus du, then the result is minus du over u, so minus ln absolute sine of u plus c, so minus ln cosine x, so at the end you add your arbitrary constant c like this. Okay, these are some simple cases of this general form. And to deal with higher powers of sine and tangent and secant x function, we try to do substitutions, and whenever we need, we can also use integration by parts to reduce the higher powers to lower powers. So what I mean is, let me put one more thing. For the higher powers here, for m and n, we will be using this trigonometric identity about relating secant and tangent. You can use this identity in this form too. Tangent square x is secant square x minus 1. Okay. Either this or in this form you can use it. And I can also put that you can first try use a substitution. Try to use substitution, either u equals secant x or u equals tangent x. Or if the substitution does not work, you can try to use integration by parts to get lower powers than you have here. Okay, so this is the summary of what you should do when you have this kind of integrals consisting of higher powers of tangent and secant x. So let's solve the first example on this. Tangent to the power 4x dx. Okay, what to do? First of all, let me also write here, we will make use of these trigonometric formulas relating secant and tangent x to each other. So this is something that we may use. Okay, let's write this function as this one. Okay, and instead of tangent square x, we can use secant square x minus 1. Okay, after inserting this and doing this multiplication, okay, you will multiply tangent square x with this first expression and then the second. So what you obtain is, tangent square x, secant square x, and then minus one more tangent square x dx, right? Okay, so here you can use, a substitution. If you choose tangent x as u, what is du? Du is exactly what you saw here, right? That's why this part can be handled by using the simple substitution. And about the second part, tangent square x, you can insert this formula once more. Tangent square x is secant square x minus 1. Okay, then what you have? So this integral is evaluated as u cube over 3, right? U cube over 3, where u is tangent x. Okay, then there is this second integral. This is a minus sign. Okay, and inside the second integral, I have this secant square x minus 1 dx. And this is something simple to integrate because secant square x is a derivative of something. Okay, tell me a function whose derivative is secant square x. It is obviously tangent x. Integral of 1 is x, and that's it. You put an arbitrary constant c at the end because this is an indefinite integral. Okay, we use this formula 2 times in this form where tangent square x is secant square x minus 1. Okay, let's move on. Next example, this is a famous integration example, and you can find lots of YouTube videos on this, by the way. Secant cube x dx. Here we will be using integration by parts, okay? So we are choosing use dv's and then we solve for du and v. You know how integration by parts works. So we write this integral as this one, secant x times secant square x dx. So we want to use integration by parts. We choose this part as u and we choose the whole remaining part as dv. Okay, how integration by parts works. Once you choose your du and dv, and then you need to solve for du and v. From here to here, you will pass by taking derivative, and from dv to v, you can pass by taking integral. Okay, u is secant x. Then what is the derivative of secant x? It is secant x times tangent x dx. Okay, like this. What is dv? dv is secant square x dx. Then v is integral of secant square x is tangent x because derivative of tangent is secant square, you know. And we are applying integration by parts here. So how it works, if you remember, I put these arrows here. If you follow the directions of arrows, you see what you need to write as the formula of integration by parts. So it goes like u times v, so secant x times tangent x minus integral v times du, right? So if you multiply, you get secant x times tangent square x. Okay, now we have a new integral to deal with, and we know that we can use this trigonometric formula for tangent square x part. Then if you do this multiplication like this and this way, you obtain what? Okay, you obtain secant x times tangent x is something already here, minus integral, this times this is secant cube x dx, and secant x times minus 1 is what? Minus integral secant x d. Maybe I should use red color here to emphasize that I am doing this multiplication and writing the terms separately inside the integral. Secant x times secant square x is secant cube x dx, then minus this times this, which gives me secant x dx again. Okay, so we were dealing with this integral where we are trying to integrate secant cube x dx, remember? Secant cube x dx. And as you noticed, the problem appeared inside my solution again. And this happens sometimes in solving integration questions. So let's denote the problem, the integration, as I. So what we have, we want to try to solve the result for I. That's why I can just collect all the i's on the left-hand side like this. We are trying to solve for it, remember? And then on the right-hand side, what we have? We have secant x times tangent x. Then we know a formula for the result of this integral. It is ln of secant x plus tangent x. So minus minus will make it a plus. Then what we try to solve for is this I, you know, then the I is the right-hand side divided by 2. Plus tangent x, it is sine divided by 2. And remember what I was. I is the original question that we're trying to solve for. Okay, secant cube x dx, this was the original problem. Okay, this is how you obtain your result, and don't forget to put an arbitrary constant at the end because it is an indefinite integral. Okay, and maybe I should put here a recall about the integration rule of secant x because we used it. So it is ln secant x plus tangent x. Like this. This is an integration rule for secant x. Okay, so that's how you evaluate the integral of secant cube x dx by using integration by parts. Okay, let me talk about on this type of integrals now, which will be the last topic of this lecture video. So these are the products of sines and cosines. So you don't have m and nth power of sine and cosine anymore. You put m and n as the coefficient for x inside, like this. So how to deal with such products of sines and cosines? You know, we have these formulas for sine times sine, cosine times cosine, or sine times cosine. How do we obtain these formulas? Let me put a recall for you. I think you remember them from high school. So what is the formula for cosine a plus b x? Okay, how do you write it? It is, in fact, cosine a x times cosine bx minus sine ax times sine bx. And similarly, you can write the formula for sine a plus bx, okay? So it goes like, in this case, cosine, or maybe let's also write the one with the minus sign. What is the formula if I put a minus sign here? Instead of plus, let's put a minus sign. Then it is the very same formula except the sign in the middle. Cosine bx, sine ax, sine bx. So instead of putting minus, this time you put a plus. And then if you sum these two lines up, what you obtain? So it goes like then, cosine a plus bx plus cosine a minus bx is what? You see, you will have a simplification here. These two are gone, so that you have the sum of these two. So cosine, I mean, they are the same thing. That's why it is 2 times. Let's write it like this. 2 times cosine ax times cosine bx. And look at here. Here, I want to find cosine mx, cosine nx formula. That's why we are just searching for this part. So just divide the left-hand side by 2 to obtain this. Okay, that's why I can write cosine ax times cosine bx as cosine of a plus b x plus cosine of a minus bx divided by 2. You see how we obtain the formula given in this row. Okay, you can also obtain the other two formulas by writing the formulas for sine a plus bx, sine a minus bx, for example. Okay, these are not difficult to derive by yourself. Now, let me show you how we use them for the integral questions. And let me emphasize these coefficients m, and these are the coefficients for the angles inside sine and cosine formulas. And for this product, for example, it is possible to transform it to a difference like this, where you put these coefficients now. For the product of sine and cosine with different coefficients inside, that product function can be transformed into a summation with these new coefficients now also here. Okay, so these formulas will make your integral much more easier because they are converting these products into summation and differences, which are easier expressions to integrate. Okay, let's look at the first example. Sine 3x cosine 5x. Okay, so what we should do? We will be using this formula where m is 3 and n is 5, okay? That's why you can rewrite it as, look at the right-hand side given in the formula. So it is 1 over 2 m minus n. Okay, sine of m minus n. Sine of 3 minus 5, right? M minus n x and plus sine of m plus n x dx. Okay, that's how you apply the right-hand side, where m is 3 and n is 5. The right-hand side looks like this now with the new coefficients. Now the product is transformed to a summation. Okay, then integrating sine of something, some coefficient time x is not that difficult. So let's integrate it. 1 over 2 goes out. What we have here, we have sine minus 2x plus sine 8x dx. And these are simple functions to integrate. How do you integrate sine? Okay, let me do a very quick recall here. Recall integration of sine kx is minus cosine kx over k plus an arbitrary constant c. So it is minus, integral of the first expression is minus cosine minus 2x over minus 2, as your coefficient k is minus 2 here, minus cosine similarly 8x over 8 plus an arbitrary constant 2. Okay, so let me emphasize these coefficients. You need to divide by that coefficients while integrating. And that's it. If you want to integrate products of this form, you will be using these formulas, transforming these products into differences and summations, which are easier expressions to integrate. So I stop here. Thank you for your attention.